So
No.
welcome everyone. Okay. Welcome everyone. Back to another round of Still Connect webinar. So I'm your host today, and my name is Rocky. So today we'll be looking into the topics of lightweight steel framing and how it can be designed to conform to regulations and design requirements. So of course, in Malaysia, conventionally, IBS is a common word, and is normally associated with prefabricated concrete panels, aka precast concrete. But in actual practice, it can also be delivered using the lightweight steel components. So therefore, today we have prepared a demonstration and also a short briefing by our expert, Mr. Chu, to take a deeper dive into how lightweight steel frame is designed from the start, meaning from a simple floor plan to a 3D design and rendering. Okay, so let me introduce our speaker today. So our speaker today is Mr. Chu. So he is an expert of framing design, and of course, as you can see from the slide, these are his background. So Mr. Chu graduated from University of Wollongong with the Bachelor of Engineering and also Master of Engineering. And throughout the years, Mr. Chu has gathered a lot of experience in terms of framing design, and now he's the framing support specialist in ENDUROFRAME building system in Australia. So without further, of course, Mr. Chu also is the member of Institution of Engineers Malaysia, or IEM, as well as the Institution of Engineers in Australia, also called EA. So without further ado, I would pass the baton to Mr. Chu, and yeah, Mr. Chu, you can take over.
Yes. Selamat pagi, everybody. Apa khabar? It's good to feel at home again with everyone from Malaysia. Yep. Thank you very much for having me to give a presentation on lightweight steel framing, and also thank you to everyone for able to spare this hour in your tight schedule to attend to this webinar. Okay, before I go any further, I am sorry I have to turn off my beautiful face so that you can concentrate on my presentation. Okay, hope you don't mind. All right, let's do that. Yeah, it's not long ago. 20 years ago, not long ago, that we actually embarked on introducing our first lightweight steel framing, especially the trusses. Those who were 20 years ago would know that this all looks very familiar. Using lightweight steel trusses to replace the timber trusses, especially or specifically in Peninsular Malaysia and also Sabah and Sarawak, and it was very successful. And we have actually moved on and improved more development and growing throughout Australia environment, and also increasingly growing somewhere in the world. Like in here, you can see this is one of the projects in China. I'm not sure where about exactly in China. And this is another one which is in another part of the world. As you can see, one of our gentlemen here from South Africa. So this is how we have grown since 20 years ago using this system. And you can see here our system provider on a global wide, more so in Southeast Asia, because we started in Southeast Asia, introducing our lightweight steel framing, especially the trusses. And then it moved back to Australia, and you can see the Australia has been very successful with that model using our ENDUROFRAME system. And we were able to give an opportunity to be in the presence of Algeria and Ghana, also using our ENDUROFRAME system. So the ENDUROFRAME system, which is a complete steel frame, which actually encompasses two main players. The first player on the software is called EnduraCAD, and the hardware is this roll former machine called Endura Roll Former. So these two integrate each other. Of course, we also have another software called Endura Hub, which integrate the whole digital technology, we call it, to offer a lightweight steel frame solution. And to go about it, we actually provide training and also support to our system provider, how to efficiently use our system, our software, to help in their projects. Okay. And as you can see, we are also very lightweight. We only need one machine, Enduro roll form machine, to generate two profiles that make up the whole complete framing system. Here you are, a C sections and a U sections manufactured through one machine. An example of this, you can see, this is a C section. These two sections comes in three sizes, 90 mm in terms of the height, 75 mm, and 70 mm. And this C section is very unique. As you can see, the flanges, the top flange is 40 mm, whereas the bottom flange is 38 mm. So this is a special feature for our system. And also for this C section, you can see there are a rib of these two sides of the web. And this rib profile acts or give us 20% strength over the rib or the plain C channel. And these C channels are meant to use for our trusses as a top cords, bottom cords, and also the internal members, the webs. And also this C rib channels is also used in our wall frames for all the studs in the wall frame. Whereas the U channel here is only meant to be used in our wall frames as a component, as a top plate, bottom plate, nogging and head and seal, which I explain later. So ENDUROFRAME software is actually the EnduraCAD. So basically this software does not need a user to be specialized in CAD skills, simply because the graphics interface ensures that the user can see the complete frame components and the connectors. And this 3D visualization enables close inspection of all the connections and blocks, which I will show you later on in the demo. So in other words, this software only do the modeling of the building, not drawing lines and whatnot. Okay. Also, this software, EnduraCAD, allows great design flexibility to meet the modern world construction, modern roof construction, like so. And also this complex roof shape can be easily modeled, detailed design with the EnduraCAD software, eventually manufactured from our dedicated roll form machine. Just to share with you, this software is also suitable for even the most complex roof design like shown here. And you can see plain and simple and easy to conform to the complexity of this roof design. And to know more in depth of this complex roof trusses. I would like everyone in the floor to, if you don't mind, do a bit of exercise. Take out your smartphone, and hopefully you have a QR code scanner. If you can scan this code here, that would bring you to this graphics here in a dynamic form. Yep.
Cindy also placed the link in the chat box. So if you are using the same device, then you can click that link also.
Okay. Yep. So here we go. When you click on the link, it will take you to this page here. Okay, as you can see, you can use your two fingers to zoom in, zoom out, or use your finger to flick it to rotate it, like so. Okay, and over here we have 5 pointers to bring to your attention. Firstly, it tells you this truss was built over the wall, and also this truss automatically notched over the wall with lower ceiling. So you can see how versatile the software is to able to adapt and conform to the structural requirement of the building. Okay. And then the next one is here. You can see this truss. It can be split into two to ease the logistic, to make it into two parts so that it can actually transport to the site easily. And the next one is, you can see the ceiling can be lowered in the hallway. So this ceiling is lowered in the hallway, so no additional bulkhead is required. So you save a lot of materials here. So again, this software is very sophisticated, and you can be able to do that. And then the next one here, you can see there's a beam hidden in the ceiling. So this would form a void block to actually have the structure beam sitting onto the wall, at the same time provide a structural support over this trusses, this truss here. Okay, and also wearing, we don't, when there is a drop in the structural wall, we are able to the roof profile, we are able to keep to the roof profile by using a cut-off truss here to conform to the roof shape. So you can see this is where the software is suitable for that complexity of a roof. Okay. And just to share with you, in the context of Australian market, you can see our system provider has actually used our software in various types of projects. Like, for example, this is a McDonald's standalone building. Okay, and then the other one will be a kindergarten steel structure building. And all these are lightweight steel framing. And we were happy to be able to provide that kind of solution to our system provider. And this is how it works. The ENDUROCAD is the software behind our ENDUROFRAME system, which sets it apart and delivers an efficient framing model. And this is how the process is. First and foremost, our software ENDUROCAD will read the architectural plan. We call it the E architectural plan, or D architectural plan, E for electronic, or D for digital. And the format of it is in a DXF format. So once that is available, the ENDUROCAD software will quickly develop a 3D model of that particular project or the house, and then it will model all the steel framing components in that model. Okay, and then the next thing is the software. The ENDUROCAD will structurally analyze and design the trusses with the input loads for to the Australian standards. Okay. And we're looking at the other components like the wall frame components. We have included structural design tables to cater for that wall framing requirement. And then it will prepare the numerical control data or the NC data for manufacturing. Right. So once all this are been confirmed and signed off by the client, then we get the software to prepare the certification for the trusses and for the wall frames in lieu of an engineer certification. This is the first software in Australia which is compliance to the we call it the ABCB protocol, Australian Building Codes Board protocol. And the software were able to generate that certification, and it not need to go through a third-party engineering certification. So next, once the sign-off has completed, all this NC data will send into our roll former machine, which has a software which is called ENDUROFRAME. And this they integrate to schedule the manufacturing orders of that project. And the roll formers will then run the orders and ready for fabrication. Okay. So once the fabrication is completed, they are delivered to the site as a finished product, like you saw here on this screen. It looks exactly like timber truss, but it is definitely much lighter for sure. And you can see you need not many person to actually lift that truss up to the roof for installation. You can see the plasterboard are easily attached to our frame. And also we provide multiple service holes to cater for the wiring or the water pipes that goes through the frame around the whole project. And also steel being very straight, you can see the steel, you don't need to actually shim it or need any packing. Okay, they being a steel, they are very straight. Okay. And then also you can see that some of our parts here are actually linked like a sausages. And if it is needed to actually assemble at the site, so these are easily packed nicely in order. And when they go to the site, when unpack it, they can know what components to look for when they do the assembly in the site. And yeah, and also you can see this system can simply screw together, and also if required, it can be easily adjusted. All right, that's my end of my presentation. Rocky.
All right.
Yep.
All right. So we are back. So what Mr. Chu just presented is basically a background understanding of ENDUROCAD, because the reason why we started with that is because it's important for you to understand how the whole system works before we dive deeper into the specifics of designing and much more technical content. All right. So Mr. Chu will be demonstrating on the ENDUROCAD software how the design can be started with a simple floor plan, and I will be posting some questions to Mr. Chu while he is demonstrating it. And if you have any questions, because I'm seeing some audience has started posting questions in the Q&A and then some in the chat box. So if you don't mind, try to divert your questions back to the Q&A so I can answer that much more structurally. All right. So with that, back to you, Mr. Chu. So I'll ask you some questions along the way as the questions come in. All right.
Yep.
So
sounds good. Yep. Thank you, Rocky. Yep. So my second part presentation to actually demo to everyone how we use our software. And for the this webinar, I have selected a simple job. as such, a single story, simple job, so that we could actually finish on time. And you can see there are some parameters which are important. I have highlighted over here, which I will need to actually input into my software. Okay. And yep. So let me unshare my slide and go back to my software, which is over here. All right. So first and foremost, that drawing that I've shown you just now, I will need to actually import into my software, and this is how I go about importing it. And this is over here. Okay. And this is how it looks like once it's imported. The same drawing that I showed just now in my presentation is all shown here. Now I actually need the plan of this building to model, and I don't need the rest. So I need to click that plan there.
All right, Mr.
Yep.
Chiu,
Yes.
I think there are a few questions regarding the system itself, but I think we'll get to that in the last
Yes.
part. So
Yeah.
I would only divert those questions that are relevant to your demonstration, and
Yes.
the rest I'll leave it to the last one.
Yep.
Okay.
Yep. No worries. Thank you. Yep. All right. Thanks for your patience. Yeah, let me show you the flow of the software. So once that's imported, and like I said, we need this plan only, and the rest we don't have to keep it in the software, so we can actually discard it. So the next one I need to do is basically just quickly show you those parameters that was highlighted needs to be input here, like the roof pitch, yep, the overhang, if overhang, and the truss spacing is all clearly shown in that architect drawing. So I need to actually capture those and put it in here. And also this one here, yep, we also need to put in the live load of the top chord, dead load of the top chord. So in the plan there, it's actually using a tile roof. So we need to put in what is the appropriate weight of the tile that the top chord will actually supporting it. And also you need to know what are the batten spacing that support the roof tiles to be restrained onto our top chord. And then we also need the point live load as per the Australian standard AS for the 600. And over here in Australian context, we assign 1.1 kilonewton as standard. And also you can see here, if this were to use in Malaysia, being the fact that we Malaysian are small in size, so we could actually use a lighter point live load to design the top and bottom cut of the trusses. Okay.
Does that mean is the weight of one person? That's why.
Yes, that's right. Yep.
Okay.
Mm-hmm. Yep. And then the next one is basically the wind load here. I'm using N3, which is equivalent to 50 meters per second. If you have anything less than that, you can select this one, and it actually tells you it's 40 meters per second. Okay. So these are all the important parameters that the software will use when they design the components. So once that's out of the way, yep, sorry.
So sorry, Mr. Chu. So just now the parameters, one thing that I saw is that there are actually different tiles, that you, in terms of weight that you selected. So it can be a heavier roof tiles or lighter roof sheets,
Correct.
right?
Correct. That's right. Yep. So for example, here we have actually 4 entry, 2 for roof sheet and 2 for concrete tiles. However, if the concrete tiles that is specified in the architect drawing is more than this value, then we need to just go in here and put in that value as specified, say for example 0.665, and then the software will use that information in the design. Yep.
I see.
So this software also provides that kind of flexibility in case that it would not fall into this 4 main typical category of dead loads.
Does it include, say, the weight of the insulation? If let's say that was the case.
Insulation. Good question. Yep. If you want to include the insulation, is the right time to actually include the insulation together with your roof tiles over here. So you need to manually calculate what's the insulation plus your tile. So maybe you could pump up to 0.69, for example, including insulation. So this is where you input that specific dead load, and the software will use that figure in
Okay,
the
cool.
design.
All right. So
Okay.
in essence, it's just the whole roof system weight.
Yep. Yep. The
Okay.
dead load, they call it the dead load.
Okay.
Yeah. Yep.
Yeah.
All right. So once that is completed, and then the next thing is basically we need to go in and start to do a modeling. Okay, just to show you how easily it is. Basically, I need to ascertain what is specified in the architect drawing using a wall frame of 90 mm. I need to make sure that that is correct, because in my system here, I have not only 90, I also got 75 mm and 70 mm. So it's good to double confirm that it's a 90 mm that the frame can be used to meet the specification of the client. So once that's satisfactory, so all I need to do is actually, trace the outline of this external wall here, like so. Okay. So you can see straight away it is actually forming the wall rather than lines. That's how we model. We model the wall and not draw line by line. Okay. Let me take this away and let me
So over here, will the frame already been constructed inside the software?
Yep. So yeah. So for the sake of this demonstration, I have actually pre-traced the wall and also the internal wall. And just to share with you, let's see. Yeah. And here you go. So the internal wall is easily traced. Okay, and you can see there's one wall missing here, accidentally not put in, so that I can show you how that internal wall can be actually quickly put in there. Okay, let's do that. Okay, let me hide this foreign cat. Okay, you can see the wall in a rush was forgotten to put it in. All right, so let's put in that wall to demonstrate to you how that is done. Okay, so we go on to the next one. New wall. I need to insert that wall there. And then okay, and if I were to hide the next time, you can see that wall is there already. So it's quickly done. using this software. And again, it is now shown very clearly now. Yep, that wall is there, together with all the openings.
Mr. Chu, I noticed that there are some color coding, the one in blue and the one in red. What would be the difference? Yeah.
Yes, the one in red is, we call it the load-bearing wall.
Okay.
Okay, load-bearing wall. Load-bearing wall is where it actually support the truss, the truss to sit on in there. Okay, and then the blue one, we call it a non-load-bearing wall.
Mhm.
Yep, so the load bearing is no, so it's not non-load bearing wall. Whereas when you click on the load bearing wall, it says that this wall is actually load bearing. It's a yes.
Okay.
Okay, so the one in red, load bearing wall, and this the red wall that actually support the trusses, whereas the blue non-load bearing wall would not contribute to provide support to the trusses internally.
So does that mean
Mm.
if let's say the owner wants to remove that wall, I mean, provided that this has been given a green light from the engineers themselves, then they can do so, the non-load bearing wall.
Yes, correct. That's right. So yep, the owner or whoever like to do a modification and whatnot, they need to get their engineer to give the green light, knowing that this will not affect anything structurally, especially the truss above the wall. Yep. So I answered
So
that
all
question.
these are counted for in the early stage, before it's being constructed. Or I mean, this will have already identified that, right? The blue would be the non-load bearing wall.
Yep. This would also be identified in the structural drawing. The structural drawing will define whether are there any internal walls to be a load-bearing wall. So we will also follow that structural drawing. And this, if this need to be a load-bearing wall, we will convert this into a load-bearing wall, if that is the case. And then sometimes
Okay.
when there's a revision of drawing, and then they say that this is not a load-bearing wall, so we have to revise our model to reflect that changes in that revision.
Right.
Okay.
So I might be jumping the gun here because there are quite a lot of questions, but I think
Yep.
after this wall is constructed, I recall straight away the trusses or so-called the members would have already been in place, right? In the wall itself.
Yes, correct. That's right. That's right. But let's finish the model first, because
Okay.
this software is actually model up. Let me share with you the right phrase to use. Yeah, this software process is actually model up and design down. So this is what I'm doing. I start with a model up first. I create the building footprint, and then
Mhm.
I move on to create the wall envelopes.
Mhm.
And then, which I've just completed, now my next step is actually to create the roof envelope. Okay,
Okay.
so once that's done, then I need to go to step 2, where I start to build down. I need to fill the roof envelope with the trusses, assemblies, and other roof components, and design it so that those load can then transfer to the wall assemblies. And yes, you're right. You can see the wall there. One, it is created, the parts. You can see there are a lot of studs in there.
Okay.
So I need to follow this process before I can show you all the studs in the wall.
Okay, cool.
Okay, yeah. So bear with me. So the next step is actually go to the roof, and I need to put in a roof block. Okay, and here you can see 22.5 is actually the pitch of the roof. So it's guided me to actually how to form this roof block in accordance to the architect drawing. Okay, I need to change this one. Sorry, let's try again. Okay, I need to change this one to a 90 degrees because this one, 90 degrees is actually a gable end, which is different from this end here, which is called a hip end. Okay, stay with me. Let me finish this process. And straight away, there you go. It has a roof block in there. And straight away, you can see. So I have a gable end here, which is a 90 degree that cause the gable end, and the rest are hip, conforming to the roof pitch of 25 degrees. Okay. And if you look back to our customer drawing over here, you can see the roof here is a bit different, not a hip. They want it to be a dash shape. Okay, so we need to comply to that requirement. So I need to do a bit more work to change to the customer's roof profile. And to do that, this is what I need to do. I do a face cut here. And then the software will be able to digest this process, and it tells you, hey, I identified the hip and hip at both ends. Is this correct? I will say yes, that is correct. And then move on to this roof block and tells you, hey, I identified a gable end here and a saddle roof over here. Okay, let's say it's correct. All right, and here you go. Now I need to add the feature, the dash shape feature. I select this roof pitch, and then I set back by 1200 as per the architect drawing. And yep, it looks correct. And it tells you this is a hip and this is a dash hip. Okay, and again, we look at our model again. And this could easily conform to the fact that we are doing exactly what the client wants us to model. And this is look exactly as the customer's house.
So this is so-called the model
Yep.
without any supporting member yet?
No,
as I
not yet.
recall.
Yep,
Okay,
this is
cool.
just the modeling process.
Okay.
So once I got this done, modeling process, now I need to actually follow the next step, which is this one here. Start building down. Okay. So the next step would be here. And then I need to set up the trusses, and straight away the software utilize the information that we have input earlier, where the truss spacing, remember, was 600. So it knows how to put all those trusses in accordance to that 600 truss spacing.
So it will be taking some time to do some calculation and distribution, right?
You can see here, it's telling you what it's doing. It's setting up the trusses now.
Okay.
9 trusses. So now it's looking at trusses 3, and then we'll move on to 4 and finishes at 9. Yep.
While it's doing that, I think it's a good chance for us to answer some questions from the floor, which I think might be relevant. So is it able to be combined into beam modeling? One of the questions.
The answer is yes. We can export this into the beam. Whole stock and barrel, our ENDUROFRAME components, everything. Yep, we can export it into the beam software.
Okay, cool. And another question, which is regarding the, and I believe it's ENDUROFRAME roll forming machine, is that regarding to your earlier slide about the C channel and the U channel.
Yes.
So the question is, any reason why U channel is still being produced even though the C channel has 20% extra strength and compared to the U channel, and wouldn't it be much more efficient to have a production line that has only one machine instead of 2 machines? So I believe the question comes in because they would assume U channel would have one machine and then C channel would have another machine. perhaps Mr. Xu, you can enlighten us of how these two channels are being made.
Okay, the reason why we have two channels or two profile is because of its functionality. We do our products, we test our products. In the beginning, we actually test our product using a C channel and a U channel for the trusses. This is specifically for trusses. And we found that the C channels is much more stronger in performance, in design-wise than the U channel. So that's why we specifically use the C channels for our trusses. And then the U channels, we actually use it for wall frames. I will show you where those U channels are used in a wall frame. And yeah, so we are able to streamline this U channel and the C channel, making use of one machine to manufacture it. So you can
Cool.
see, yeah, how this come about. And we were lucky that only one machine can actually produce these two sections, complementing each other.
Yeah, so to be clear, it means that one machine itself can produce both C channel and the U channel.
Yep. One machine is producing two sections, but they produce one at a time, not roll together at the same time. Yep. That is clear.
Yeah, and the sizing also, because there's another question that I believe from Malcolm, standard sizing and dimension of the C sections and baton. So I believe that was already shown in the earlier slide.
Yep.
Of I think 48 mm and up. Yeah.
Yep.
Anyway, yeah, that one I think we can answer privately.
Yep.
Let's go back to the demonstration.
Okay, thank you. Yeah, so you can see all the setup trusses are done in 87 seconds or thereabout. And then next step is actually finish the design so that all the loads can actually fall down or transfer down to the walls. So as you can see, all the trusses are set up and still not designed yet. So so we need to design. That means we need to change this word unknown to either design pass or fail. So to do that, we can come here and all trusses. We can auto design all trusses fixed web. So this is again another process. Yep, here you go. It is actually running all the commands there. And while we let it finish, is there any other question that I could quickly answer also?
Okay, great.
Yep.
Yeah, there are a few questions. So I think some are jumping the gun here regarding the wind loading, because I believe later we'll be sharing how to actually improve the design to withstand a certain wind load. They are also self-certifying, self-certification in lieu of engineers endorsement. So that one we will come back after the design of the trusses has been done. And okay, so I think maybe during this process, right, it's good to also answer this question: is this enduro frame or enduro can it be designed and calculated and verified by professional engineers?
Yep, I'd love to answer that question also later on.
Yeah. Okay, good.
If Rocky can put in a parking lot there so that you won't miss.
Yeah.
Thank you.
There are overwhelmingly a lot of questions. So okay, maybe this is more towards the EnduroCAD. So is the software used developed by BlueScope, and is it available for engineers to use? So engineers means engineers publicly.
The software is BlueScope designed and made by BlueScope since day one. And over here in Australia, we have engineers also using our software simply because they are now much needed to actually lightweight steel, very popular now. And so the engineers also needs to equip themselves with all this knowledge. And I think they found out that our software is suited for engineer to use, and that's why we have our engineers to actually consulting engineer to actually embark on this software to get themselves familiar with the lightweight steel frames design. Yep, hopefully that would answer your question. Yep, we also sell our software to our consulting engineers, if that's the question.
Yeah, I believe that is the question here.
Yeah.
Yeah,
They
so
can buy our
does
license and we can organize that.
all right,
Yep.
cool. So I believe the trusses are done.
Yep, the trusses are done, and
Okay.
yep. I have one here. You can see still unknown.
Mhm.
Okay, and let's look at it why it is unknown, whereas the rest of the trusses are all design pass. Yep. So at least I got something to show you all why it is unknown, rather than all pass and then you don't learn anything. Okay, let's quickly yeah.
So just to explain a bit what the audience are seeing, the green ones on the left, those are already
Yep, those are
passed.
already designed and pass all the codes stipulated in AS4600.
Mhm.
Okay, and let's look at this one here. When I left click on this one, it tells me I'm looking at this truss. So this is very focused, this software. So at least we know what we are looking at and what we're dealing with. So now we come back to this truss here, and let's go in and have a look why this one fails. Okay. And you bring up this screen here. Okay, so usually we click design fix web here, and then we go and check, and then it tells us, hey, hang on, that's not enough support. So that's why the software will not proceed with the design. So that's how the integrity of the software, where the model is correct, the software knows what to do. When the model is not in line, the software will know and prompt you, hey, I cannot move on because there's no support, I cannot design. Okay, you guys with me? So I stop
Yes.
this one. Okay, I stop this one and have a look at this model closely. And if you can see the trusses next to it, you have these blue dots here. Okay, so the software understood this model and these blue dots here, saying that there would be a support there. Okay, however, because it's so close to the edge here, and the software was kind of confused, so it stopped designing this software. So I need to make it right. So what I need to do is basically, let me close this one. Let me quickly show you this model in 3D. Which is over here. Okay. As you can see, I have a gable wall here. Okay, and so happen this gable truss is actually very close. In fact, clashing with that wall there. Okay, so what I need to do is to avoid this conflict. So I need to manually have the software to move these trusses away from this cable wall so they are not conflicting with each other. So maybe because of that one, so that's why the software is not able to put in a truss support like shown here in blue triangle or at this end. Okay, so let's do that. Let's go to plan view and let me click on this truss. Okay, and move by distance. Okay, I want to move inwards. That means I want to move into the negative direction. So I put negative, say maybe I move in about 100 mm into the building. Okay, you can see straight away that it's been moved, and straight away you can see something is happening. You're able to detect the load bearing wall, and it puts the support for the trusses there. Okay, and now I go back to that truss list. And now it's able to understand the action I have done, and then it actually group that truss that I've moved in by 100 mm to be the same truss as the other truss. So now it actually grouped into truss 8.
I see.
So we have some intelligence in there.
So this is basically the roof truss section, right? So
yeah. So let's look at this one. Yep. So this is that roof truss, and this is how it looks like real truss. That means the real members and all those things, bottom chord and top chord, and with the webs. Okay. So for
Mr. Chu,
instance,
if I may stop you there, can you explain a bit about the design status? What does this mean? Of 80% pass, 86% pass.
86% pass. Yep. Okay. Good question. Let me show you behind the scene, the engineering part of it. Okay. Comes another screen here. Okay. And then right now, sorry. So right now, this software is looking at load case 136, which is the worst case scenario, and it's designed to Australian code AS4600. And load case 136 combination of dead load in load case 1 times factor 1.2, and then plus load case 15, which is a bottom point load, with a factor of safety 1.05. Okay, and if I were to show the applied loads, here you go. So this is the load case 136. Okay, so the dead loads plus this point load. So this would give us a worst case scenario, and you also give us the reaction due to this load case 136. And also you're talking about that performance here. What was the performance just now there? You're talking about
86% pass.
86%. You can see here 86%. So it's referring to this connection here that is working very hard compared to other part of the components. So due to this load case 136, this gives the worst case of 86%. So that means that it actually utilized 86% of its capacity, which has a reserve strength of about 14% there. So it's working very hard compared to the other part of the components of the roof. So if we were to look at next load case, you can see it is 66% due to this different load case. And different load case. So the software is clever enough to pick the worst case scenario and tell us that, hey, due to this load case 136, its design performance is 86%. And so that you know, inside this software, it has all coded all the needed, required loads and loads combination that is specified in Australian standards. So we have primary loads here, dead load, live load, and others, which constitute about 18 load cases for the primary loads. And then from 100 onwards, load case 100 to load case, can you imagine you do it by hand? Yep. To load case 139. So there are 39 load combination cases that the software would design accordingly that is needed in the code. And then last but not least, we have starting with 1000, we have 1000 to 1023, so that we have 23 load combination cases to design to look after the deflection of this truss. So this software is very, very versatile in that sense. It take into consideration all the possible load combination in the design process.
Right.
Yep.
This is true. Is it able to basically I mean, just now you mentioned 86%, right?
Yep.
Are you able to improve the so-called reduce the capacity? How to say? Basically reduce the percentage to a lower percent so that it doesn't get so close to the the capacity load.
Okay,
Meaning,
before we go any further, so so here we can actually get the software to calculate the performance of that connection here, and that's where the 86% comes in. Okay, and over here, this node actually has got 8 number of screws that we have actually test data stored in the software to understand and to be able to provide a very efficient design in terms of our product scope. So back to your question, let's close this one. And go back to this one. Yeah, so like I said, it's shown 8 screws, or if you were to look at here, we also have a label and tells you that this is a 8 screw connection. Okay, so when I click here and edit this node, and then it has stored for this node a few types of required connection, and the software will actually use this information here to do the design process, and it will pick the right combination of screws that could satisfy this design. So as you can see, it started with 5 screw, and then 6 screw, 8 screw, 10 screw, and 12 screw, and it goes all the way to some other combination. And the reason why it stopped at 8 is because it knows that it is very close to 100%. Anything over 100%, it will fail the design. Okay, so for example, I want to use the 5 screw here to test the design. So I go with the design using 5 screw, and then it will straight away tells me, see, it is not able to restrain the design requirement with 5 screw.
Okay. So the screws are, even though it's so minute, that but it plays a huge role in
It
the
does.
integrity.
It does.
Yeah.
It does. It does. Yeah. Yeah. So you can see it. I get it to start at 5 screw, and it understood, and it go into the design process, and straight away tells me that 5 screw cannot do the job, and is failing at 134%. So that's how accurate the design using this software. Yeah. So I will let the software make the decision and let it run, and straight away it tells you, okay, here you go, 8 screw is good enough.
All right, Mr. Chu.
Yep.
So I believe after this modeling, as you mentioned earlier, model up and design down. So after this process, so after the roof truss is in place, the next will be the wall frame, right?
Yeah, the next will be wall frame, but let me quickly show you beside the engineering part, I could able to generate assembly drawing, because the people needs to assembly these components, they need some kind of drawing. Make sense? Yep.
Makes sense.
Yep. So so the software able to generate we call it the truss fabrication drawing. So the people at the site, once all these components are rolled out, cut to length, so they need to make use of this fabrication drawing. We call it truss fabrication drawing to actually put it together to form this truss so that it can actually conform to the design of this and also can can do a quality check easily using this fabrication sheet before they send out to the site to do the installation. So you
All
can
right.
see they're
Yeah.
integrated with each other very well.
Mr. Chu,
Yeah.
I have a question specifically for this, the drawing that you just shown,
Okay. Yeah.
from Alfred Lee. So the question is that in Malaysia, we have cases where the design is being ordered, but then the installers themselves are not accredited because of high turnover rate from the workmanship. So does this document allow, say, for example, any qualified person to basically do self-checking? And does it require, is it mandatory for the engineer to certify the completed structure?
Very good question. First and foremost, of course, all this need to be trained. We can assure that the excuse me, we can assure that the training can be minimum. Because our system here, you can see here, is called a smart. Smart meaning that all the holes here are already pre-punched by the predetermined by the software and pre-punched by the machine. And when they put this together, the hole has to align. When they are aligned, meaning that it needs a screw there. So if you do a quality check, you can easily see that, hey, there are holes, but no screw. That means it doesn't meet the requirement. Check. It doesn't satisfy the check. So that's why our software has our system has improved a lot since 20 years ago, where all this area where need the screw, they actually have holes in there.
I see.
So thereby they use this to do a quality check and they can do it very fast. Any members that are aligned, the holes are aligned but no screw, that means they are not doing the right thing.
So it's quite foolproof.
Yeah, it's quite foolproof. Correct, that's right.
Okay.
Yep.
So I hope that answered your question, Alfred.
Yeah. So as you know, the labor here in Australia is very expensive. They cannot hire a lot of people like in Malaysia. So yeah, we were able to provide this kind of support so that they can minimum train their staff and actually do the work efficiently using our system.
All right.
Okay.
Hope
I answered your question.
Yep. So time for the framing.
All right, time for the framing. So we have done the design of the trusses, all good. And before I move to framing, I also need to put the rafter there to make it complete. So this is how the software will do it.
Oh, okay.
Yep.
So it's calculating.
Yep.
Cool. Well, there are some questions about very specific the design criteria, particularly on long span structures, comparing it to mild steel or structural steel. So I'm not sure whether off your head whether you can come up with any experience that you have encountered designing it for 16-meter span structural steel roof truss with 900 depth truss. 900 I believe is mm.
What does it carrying? A metal roof or concrete tiles? That's a question.
Yeah.
But look, this software is an engineering software. Yeah, we can use the software to satisfy your what if span of so much. Yep, it can easily show you how good it's designing and what failed and how to actually minimize the failure, that kind of thing. So yeah, I
Yep.
mean, this software is fantastic, user-friendly and easily to explore and give you an answer to your what if question. Just to share with you, we have done, this one is carrying metal roof, by the way. We've done an 18-meter span, not an issue. But again, it depending on the wind loads and whatnot, yeah, that is subjected to the wind load condition. But you
Meaning
can,
the entries that you put in earlier.
yeah, correct, that's right. Yeah. So
Okay.
yeah, let's yeah. So you can see
All right. Let's move on.
the rafter is already put in there.
Mhm.
And now looks like the roof is complete. All right. And yeah, before I forget, I thought that maybe yeah, let's finish before I yeah.
Yeah.
Yeah,
True.
let's do that now. Okay. So once that's done, we move on to the wall. Okay, and let me put in the 3D view. Okay, you can see the wall are still not built yet. So I need to go to the wall. Okay. And let's create all the walls. Okay, I click create parts, all wall whole job. And you can see down here is building the wall, calculating and all those things. So it's understood my command is go ahead and do that. You can see all now the walls are being created, and you can see all the studs in place where it should be. And also the openings also are being created as you create the parts for the wall panels.
I think there are a few questions that are asking how does the design get translated into manufacturing, which I think after this, once you have concluded this design, then we can get to.
Yep. Mm.
But one question that I believe, if I may just compile everything, and some of them asking about self-certifying and all that. As I understand it from our discussion, is
Yep.
the outcome, so-called the percentage pass that you shown earlier, like 83% capacity, those are based on tested data, right?
Correct.
Not really a simulation per se. It's based on the tested data and then put back into the software.
Yep. Yep. That's right. All our products, not only our this ENDUROFRAME system, all our roofing sheets, even our purlins, even our bond deck, and all these products are all tested so that we would better understand
Mhm.
ourselves of our product than anything else. So that's why the specifier have confidence using our products. They know that we deliver what we promise. Yep. Of course, this one comes with a price, unfortunately, but I think we like to sleep easy, isn't it? Not to wake up
Yeah.
nightmares, cold sweat, that kind of thing. Yeah.
So when I think when it comes to when we say self-certifying,
Yep.
as I recall, it does not just power the software itself. So it has an extent to who is designing it. Is that correct?
Look, the software has come to a phase where it is now able to provide a good system to satisfy the user. But again, garbage in, garbage out. But as far
Mhm.
as the integrity of software, we gather it very seriously, challengingly, so that this will not be actually misused. Uh, I mean, just to share with you, since we are on this topic, yep, here you go. In our test lab, all these are actually tested in real life, real truss, I mean. You can see here all the testing rig.
Mhm.
Yep, all full-scale testing, test to destruction, so that we know how much to push the boundary. Yep, so here are all the records that we keep when we do the testing. And all this information are then translated and put into the software that we can use and utilize it.
All right. So I believe the framing is completed.
Yep, the framing has completed. And yep, the job is done. And let's have a look at this wall here. All right, so we're looking at the gable end wall here. And over here, you can see we have a color in red arrows. Okay. The software also able to detect, hey, that's something clashing or something not right. Just to forewarn the user. And it tells you, here you go. This area highlighted in yellow, warnings. So need to look into deeper what causes that warning there. So we have trained our software to and the software user to actually know how to look at this thing. And you can see, yeah, sometimes there's some clashing here, and the software user would know how to actually resolve this issue. So you can see there are two components here that clashes. So all the user need to do is actually either, let's say, okay, let's say quickly remove this. And by the way, this one is a nogging, we call it, and you can see up here, it's called a U section. Okay, and this is how it looks like.
So the U section that you
Yep.
shown earlier.
Yep, that's right, the U section. See, it's a U section. And this is used for the nogging and for the top plate and the bottom plate. Okay. And then since we're on here, we can look at the C section. And here you go. This is the C section. So you can see the software are very integrated with our machine because the machine would able to take all this information and roll up, cut to length, and then all these survey holes will punch accordingly to the design. Yep. All right, so let's delete this one, for instance. Okay, and then let's extend it. This one to end here. Okay, let's try again. So I want to extend this part to over here. Straight away, you understood. Okay. And then I can regenerate the numerical data. And the software will do the check and let you know, hey, you did something good, but still there's some warning there. Okay, and then highlight. Yeah, tells me that, hey, you gotta look into here and see what is not right. Over here, I have made the change and it is happy. It didn't show me the warning at this side, but I purposely did not make the change here, and it still recognize that there's something not right there. So before it goes to the machine, it already been checked in this software. Yeah, so there's no material wastages, unnecessary, that kind of thing. So everything is in 100% good to go.
Okay. Perhaps is there's another question since you raised this up that might be relevant. So, when the design software is used by an engineer to design buildings, can the output of the design be manufactured by other manufacturer with any roof forming machine?
The simple answer is no, provided those machines are made from the same manufacturer. But again, not necessarily the manufacturer that makes other machine has the same requirement as what we put in our software. Yeah. So I would say 99.99% no, you can't use in any other machine to manufacture ENDUROFRAME's system, because ours is very special.
Okay.
Yeah.
So now it's fixed, the one on the right.
Yeah. Okay. So let's recreate the NC data and we'll check again. And we look at here. Yep. It's no more red color, so it's all fixed. Okay. How much time do I have left?
Probably very little. I mean, we almost shot by 15 minutes, but just a last part before we, you can sign this off as so-called a design.
Yep. So once the design is satisfactory, is satisfactory by the client, by everybody, then we can actually lock in the order. Take the down payment from the client, and then we can actually sign off this job and lock in everything, sign off, and then everything is locked and you can't make any changes anymore. And then this one will actually goes to our Endura Hub software in our machine, and we will pull in all this NC data and process and manufacture all the parts.
Okay.
Yeah.
All right. So last question, because I think there was some that was asking about wind load.
Yeah.
And I believe that the concern is, due to the changing windy condition, or I mean, not just in Malaysia, but also across the world. So as the parameter that you said earlier, 50 or 50 meter per second wind load.
Yep.
So if let's say the condition changed, right? So you had to change the whole thing from ground out, right? As I recall.
Yep. So right now it's using 50 meters per second. So in case you have a similar project, but in a different geographic, with different wind load, say maybe 66, for example. So click OK. And then it tells you here, hey, hang on, you have made some important changes here. Okay. So we give you a warning. These changes only affect the new roof block and trusses. So you may automatically update all the existing trusses now, or you can manually update them later. So the software is smart enough to say, hey, you have changed some of the parameters that affect the design, and what it works before, now you have changed it, it's no longer work for this new parameter. So the onus is on the user. With this warning in front of the person's face to, hey, I can help you to update all these trusses now. If you click that icon, or you want to update them later. So it's up to the trained software user to make that decision. Okay. So in this case here, I have, say for example, I want to update all the trusses, and the software will do the update there. And when we go to our truss list, you can see all the parts has now become unknown. So whatever was designed is all down the bin. And now it will design based on the new
scenario.
Yeah, new scenario. So let's quickly do a quick one.
I think there was a question about the Malaysia scenario. Do we need to design to 50 meter per second? What would be the wind load requirement?
I think you have to look at your sorry, your topography chart, where it tells you what area has what wind load. I think Malaysia wind load is pretty mild.
Yeah, pretty mild. I think
Yeah,
40
but
is
yeah,
quite high
but
already.
yeah,
And
typically about 32, 33 meters per second. That's how I know 20 years ago, 25 years ago.
mhm.
I'm not sure about now. But yeah, even in Australia also, we refer to our code AS 1170 Part 2. That's the wind code. And it has a big map of Australia. And it shows you what wind is needed to satisfy your design, depending on where the location of your project is. So we use that as a guide to use the right wind load in the design. I think same goes to every part of the world too. You need to have some kind of guidance and to design it accordingly.
Okay, so last is this will be the last question I think before.
Yep.
Yeah. Yeah, are you going to show the web design?
I just quickly shows you with this new 66 is it, meters per second. I need to show you another sheet that generated by software. It's called the engineering sheet. So for this truss here, okay, it passes and it tells you the, yep, here you go, 66 meters per second is used in the design for this truss. So it is that design focus. So you can change it and you can get the software to redesign based on your new information. And here the engineering sheet will tell you exactly how each of the trusses perform based on this new wind speed of 66 meters per second. Okay.
Okay.
Yep.
Yeah. So, but what you just demonstrated is only for one section, right? It's not for the whole thing. It will take time to.
Yeah, it will take time. The software will able to do that, but again, it's good to manually check it so that the software is not misbehaving.
Mhm.
This is how we train our software user. Yeah.
So, yeah. Last question before we close this demonstration
Yep.
is the software able to assist to determine where to apply the bracing on truss and frame?
Yes, the software able to determine the bracing. As you can see, when it actually create the parts, it straight away knows where to actually put in the bracing according to the code. And again, the user manual has to actually check whether that bracing that the software has put is enough to satisfy the capacity of the wind load. And quickly to show you that, yeah, here you go, the wind load, like the wind load calculate and extract all this information. Oops, sorry. And shouldn't take long, only 12 seconds. So once that is done, so we have a look at here, and the software will quickly give us a answer. Yep. So based on this 66 meters per second, okay. Yep. So the total load capacity due to this wind is 33.49 kilonewton, but the bracing capacity that the software put in only can come up with 10.6 kilonewton. Okay, so this tells us that we need to pump up this figure to equal to this total load or greater than this total load to satisfy that wind load requirement. So this is for the wind blowing this direction. This is the condition. And for wind blowing in this direction here, and this is what the software has actually calculated, showing that the strap bracing that the software put it in is not sufficient to overcome this total load of 28 kilonewton. So we need to pump it up. So to do
I see.
that, just to show you quickly, let's pump up this 10.6 kilonewton. See how much we can pump it up.
So clearly this would take the whole redesign if let's say we were to comply to that requirement, the load requirement that you showed earlier.
Yes, correct. That's right.
I see.
Yep.
So you're just trying to get closer to that requirement rather than passing it.
Yes, that's right.
Okay, cool.
Yeah.
Cool.
So to do that, just for the demonstration purposes, we can quickly put in a strap bracing. There are a list of strap bracing to put it in, for instance. All right, and then we can put front and back or both side of this wall. Okay, let's put both side and let's try this one. Okay, so we put a bracing there, and then I put another one on this side, for instance. Okay, so that has been done, and we can quickly let the software do the calculation again. To calculate the wind load again. Recalculate. Okay, it's putting the sheet down. And very quickly, we can now relook into that wind sheet calculation. So we need to improve that 10.6 kilonewton to be better than that figure there. So you can see it has gone up 10.6 to 23. So we still 10 kilonewton short. So we again needs to manually, put in that more bracing to make sure that it is able to withstand that 33.49 kilonewton of wind force. So you don't have to calculate by hand.
Yep.
Okay. Sorry, I've overrun the time.
It's fine. All right. So let's just get to the Q&A.
Mhm.
Okay. So yeah, Mr. Chu, you can actually unshare your screen and then I can share mine.
Yeah.
Just to close this. There are a few questions that I think we can answer quickly before we end this. But there are actually a lot, much more in-depth questions, which I think we need to channel back to Mr. Chu if let's say we can answer it over here.
Yep.
Okay, so let me just quickly glance through. Okay, so long span just now, I think we mentioned, you mentioned there was an example where based on the criteria of 18 meters,
carrying
yeah,
sheet roof.
yeah, sheet roof. So it is case-to-case basis rather than generalizing it that 18-meter can be done for all kinds of scenarios.
Yep, that's right.
So yeah. So there is also questions about the standards because as you have demonstrated earlier was that most of the design code are linked to Australian standards and also rightly so tested in an accredited lab to reflect that. So how about the other, say for example British the Eurocode design standards, would that be something that this software can also meet in terms of requirement?
Look, because right now all our system provider are Australian user. I mean, we still have some system provider in Southeast Asia, but most of them, if I'm not wrong, are trained in Australia, so they are confident. to use the Australian standard, but we do not in this short term look into putting in the Euro code or any other code in the software as yet. But yeah, but we are open to suggestion. We would like to see how we can actually best to provide, or rather, we would like to work with our business partner to see how best we could actually assist them. But as of now, everybody is happy with the Australian standard, so we are using it only with Australian standard. Yeah, thank you.
All right. So there's another question that comes up about the load allowance. For example, if the owner wants to add additional, for example, the flamboyant, the example is like add a chandelier, right? Or ceiling aircon. So how would the design be able to cater to that prior to them even accounting for those additional load?
The additional load, like what you mentioned just now, can be added in on top of the required load. We call it the user load. The software would able to provide those additional load to be taken into consideration in the design aspect of the truss by using the user loads. Yep. So any additional load can be
can be accounted for.
Yeah, can accounted for. Correct. That's right.
Okay. All right. So does the truss roof trusses have to be aligned with studs in load-bearing wall?
Does the roof trusses? The roof trusses has to sit on a load-bearing wall.
Okay. Okay.
Yeah.
It is compulsory lah. That means.
Yes. Yes. Correct. That's right.
Okay.
Because it has to have some structure to transfer the truss load down to the foundation. So that wall has to be strong enough, and that wall we call it a load-bearing wall.
All right. So, regarding the spacing of the trusses, is there any design tolerance in between the two trusses?
So,
Like for example, like one web from another web.
sorry, I lost you there.
Sorry.
Can you repeat
Meaning
the question?
the roof. Is there a design tolerance in placing the distance of the trusses from each other?
The tolerance of the truss spacing, we call it, according to what type of roofing material is being used. I mean, for concrete tiles, it's very heavy, so the truss cannot space apart further away compared to if it carries a roofing sheet. For example, if it's a roofing sheet, we have trusses spacing at 1200 or more. And if you carry concrete tiles, then the trusses can be 600 or up to 900, depending on the location of the project, depending where the wind loads, how strong they are. Yeah. So hopefully that answers your question.
Yeah. All right. So just now there was a long span roof, which I believe from CC Lim that we have answered. So of course we will come back to you after this to if let's say you have any more questions that we can cater to personally.
Yep.
Or with our system provider in Malaysia. Yeah.
Yep. More than happy to answer all those questions if we can. Yep. Please do that.
Okay.
Thank you. Yep.
So there is one which talk about regulations. So I'm not sure whether Mr. Chu, you are able to answer that. It's regarding bomba for building, bomba requirements for building, especially the residential and terrace houses. So is there any past experience or solutions on complying to bomba requirements in Malaysia?
Such as any specific bomba
So
requirement?
I think this is kind of a regulation thing. So I think we are not able to answer this, Mr. Fu. So Yeah,
Right.
we'll come back to you on a personal level then.
If he can give us more information, and then we know exactly what question you are asking, and then we can provide you the proper answer. Yep. If I cannot answer, we have experts all over the place, including Australia, who has all worked with Malaysian counterparts. Yep. Before.
Okay. So yeah, just now the questions was from Mr. May regarding if let's say the software design the so-called the structure frame and all that can it be used or produced by another roll forming machine? So I believe your answer earlier was no.
Correct, that's right.
Yeah. So so I think this is can the outcome of the design be integrated with the detailing and manufacturer with the ENDUROFRAME system? Meaning whatever you just designed. So I believe during your presentation, you have shown that it can be integrated, and it is integrated, right?
It is integrated. Yep.
Okay.
Yep.
There is one very technical questions regarding the centroidal axis offset from their web. So I think we can address this later.
Offline.
Yeah, offline, because this one quite technical. How the software determine. Okay, so Mr. Fong, just now regarding the questions about whether the software itself will assist to determine where the bracing on truss and frame will be placed. So I believe you have demonstrated that earlier.
Yep.
And it's just upon that, if let's say the wind load change, for example, then you need to
redesign the whole thing again. Do more.
Yeah. Okay. Right. Okay, so are the sections all designed to one single thickness, meaning the C section and the U section, or it can be varied across like different thicknesses?
Each profile, the U and the C, we are very clear where it's going to be used. As far as the U section is concerned, it only meant to be used for wall frame and not the trusses.
Okay.
Yeah.
So hope that answer your questions, Joe. Okay, the next question is more on accountability. So from Eng, so who will be liable if let's say the error happened in the software itself?
In the software itself.
Yeah.
I
As
don't
I
get it.
understand, as I understand it, the software has already been it is a self-certifying software, meaning it is accredited by an accreditation body, right?
Yep.
All right. So would there be any error if let's say someone used the software and there was an error, or there is no error to be found?
Look, the accreditation of the software has been a self-certifying software. Also lay out that the user has to be trained, and we are providing that training also. And again, the onus is on the user that they, upon training, they would actually, how do you call it? We provide them a certificate saying that they are being trained proper and they are actually responsible for the job done. So the responsibility is fall back on the user to ensure that everything is in accordance to how the training has trained to him. So yeah. So especially the structural thing, that's why our trusses are all designed internally using the software. We ensure that there's minimum requirement for the user to actually meddle with the design. So so we assure that that truss design is not what they call it tamper with. So once they tamper with, the whole design just become void. Like you saw when I changed the wind speed to 66. All the design just throw out in the window already.
Yeah.
So we assure that that integrity is in place and nobody can actually, because it's got to do with life and death. So we are very careful with that one. So yeah, so we take care of that aspect. And the others is where we do the training to our software user to also have a checklist to actually make sure that everything has got no error in it. Yep.
All right. So let me just go to the last question because looking at the time.
Yeah, looking at the time, I live for another appointment.
So okay. So there is a size in terms of dimension. For the holes, yeah. So the pre-punch holes that you mentioned earlier. Is there any dimensions? I mean, would it have a certain tolerance, and how do you handle the discrepancy?
What kind of discrepancy? Sorry.
Meaning the diameter of the pre-drilled hole.
The holes are predetermined in the testing, and that testing has given us the results, and we actually ensure that that determined holes are actually manufactured accordingly to the testing, and all these holes are actually complying to the code that governs the screw holes, the holes of the screw sizes, and all those things. Yeah.
All right. So it has already taken into account of
Yes, it has.
all the practicality of producing it as well as assembling it.
Yeah, that's right.
All right. So with that, I would like to conclude today's session. Of course, for those questions that are not answered, we'll get back to you on a personal level, by email, or we'll give you a call and all that. And hopefully, most of your questions are answered, and we hope you enjoyed today's session. And just a reminder for engineers or architects who sign up also to collect your CPD points, you may scan the QR code on the right here, where you can submit your your LAM or BM membership number. And I believe Cindy will also post it in the chat link. All right, and for you to access if let's say you are using the same device to submit those. And also, if let's say you would like to have an overview about the IBS using steel, actually back last year we hosted another Steel Connect webinar that briefly talk about the overview of IBS using steel or lightweight steel in general. So you may go to the link which Cindy will also be sending via the chat box. And with that, thank you everyone for joining today's Steel Connect webinar, and we hope to see you again in the next session. All right. Thanks everyone.
Thank you everybody. Stay safe. Take care.
Yeah. Talk to you soon, Mr. Chu.
Yep. Bye.
All right. Thank you. Bye.